Hi, and welcome to this Fundamentals of Airflow Monitoring Stations. My name is Greg Hoyer, and in this session, I'll be discussing some of the different airflow monitoring technologies available. Now, to begin with, the distribution of conditioned air is still the primary means of heating and cooling most commercial buildings today. Proper airflow control within a building is not only important for the health and comfort of the building's occupants, it's also important for the health and long-term performance of the building. Accurate airflow measurement allows the HVAC system to work as effectively and as designed, efficiency as well, and required to meet the ever-increasing energy conservation goals. Two most common airflow monitoring technologies are the differential pressure method and the thermal dispersion method. Today we'll be concentrating mostly on the differential pressure method. This is what we normally see in a VAV system. Most of the contractors that work with us are very familiar with VAV systems. Okay, to start out with, from a theory standpoint, differential pressure technology is commonly used to measure fluid velocity due to their well-defined relationships. The square root of the differential pressure is proportional to the flow rate velocity of a fluid. Now, in ducted systems, the total pressure consists of the velocity pressure and the static pressure. Velocity pressure cannot be measured directly, it must be derived. By measuring the total and the static pressure in a duct, the velocity pressure can be attained by subtracting the static from the total. This is achieved in practice by directly measuring the differential pressure between the two. So how is this achieved? The differential pressure, and the most common way that we will see this done is with the Pitot Tube technology. Everybody in the VAV system notices the crosshairs that they'll see in the ductwork. Now you have small holes that are in the airstream, and it's usually in a crosshair configuration, but some of them are in a straight tube that goes across the entire duct. You will have small holes that are facing the airstream and small holes that are facing away from the airstream. The small holes that are facing the airstream is the total pressure in the ductwork. The holes that are facing upstream or away from the airflow are the static pressure. And we measure the difference between total and static pressure, or measuring the differential pressure. And this is measured, this is what's measured in what's called velocity pressure, and it is measured in inches of water. Once we get our differential pressure in our ductwork, we can calculate velocity by multiplying 4005 times the square root of the velocity pressure that we achieved through our inches of water measurement. And then to get that data will of course give us in feet per minute. Once we have feet per minute, we can calculate CFM by multiplying the area times the velocity. The area is, of course, the inches in length by inches in width. That number is then divided by 144. And that gives us our square feet, which is then multiplied by our velocity that we've calculated. The area of a circle is pi by r squared, which is the radius of the diameter of the circle. So that would be the 3.14 times the radius, which is half of the diameter, squared. Some of the different Pitot tube arrays that you'll see common in our industry is the the averaging pitot array station with honeycomb. Now that is a inserted into the ductwork, into the airstream, and you'll have a honeycomb configuration which straightens the air so that it hits our total and static pickups. And that's shown here, another form is the pitot static tube, which will again be put into the airstream. The averaging pitot array technology is right here. Often you'll see that for supply air calculation. And in the bottom screen here, on the bottom of the screen here, you'll see a combination pitot array and damper. They can be purchased so that the damper and the airflow monitoring is in the same configuration purchased from the manufacturer. The terminal box flow cross ring, this is what everybody's mostly familiar with in a VAV system. You'll see the crosshair in the middle of the screen here for total and static. Now again, the total is the airstream, the holes in the pitot that are facing the airstream, and the static is the holes that are facing away from the airstream. And then they pop out into our VAV controller typically, and we measure our differential pressure in inches of water with our flow bridge usually that we see on our VAV controller. You can also, like in the top left, you can, on the bottom right, you can purchase a combination pitot array damper with honeycomb. It's probably the most expensive form, but most definitely the most accurate as well. In this configuration, again, it goes into the ductwork. It's purchased by the size of the ductwork, and it is inserted into the ductwork. What's missing from the picture is the transmitter that will plug in our static and total pressure ports for measuring our differential. All of these technologies, these pickup tubes and arrays that you see on this screen, are for the direct, that usually it's seen inside of ductwork, straight pieces of ductwork that are measuring an airstream of some sort, whether that's outside air or supply air, downstream of the motor or upstream of the motor, but these are inserted into ductwork typically. On this slide, we see the different forms of fan inlet measuring pitot tubes. And you will see that there are averaging type, which go across the inlet of the squirrel cage, as shown here. You also have on the inlet of the bell of a fan array, and these are typically averaged together so that they're all commoned up. In this slide, we see the Johnson Controls differential pressure airflow measuring system. So this is including a damper motor as well as a differential pressure transmitter. It's shown right behind the actuator over here. But in here, you'll see in the picture here, you'll see the honeycombed arrangement for straightening the airflow. It's then sampled through our static and total pressure pickups, which are then plugged into our airflow transmitter on the side of the measuring system. And it also includes a damper and actuator that will be used to vary the flow based upon a set point. Some of the nice features about this is it's supposed to be easy to slip into existing ductwork, so it's flanged. It also provides a factory installed actuator, which reduces the installation and commissioning time. That's supposed to help us in the field a bit. It's factory pipe differential pressure with display, so that the transmitter that you see on the side also has a display on it, so it will produce a value as well as report one back to the building automation system. And we have also vertical anodized aluminum sensing blades, and this is allowing for very low airflow measurements. Now, this system is the AD 1250 differential pressure airflow measuring system. Our next slide shows the AD 1251 Johnson Controls differential pressure airflow measuring system. Again, it has a probe that easily slips vertically or horizontally into the ductwork. And you'll see that the plate on the side here accommodates any kind of openings that you're going to make into your ductwork. The transmitter that you see mounted to the side of this bracket or this plate already has the pickups associated with the static and total airflows wired to it. Also has a display on the transmitter for local readout, as well as the ability to report back to a building automation system. It's intended to be used in retrofits, so existing ductwork, something that you're not, taking the ductwork apart for. Like on new installations, you would use the 1250. This wants to be used more on existing configurations where you would just cut a hole in your ductwork and insert this into the existing duct. Okay, to recap what we've just gone over, the different airflow, differential pressure, monitoring, airflow pickups, we need to first achieve our velocity, and this is measured in feet per minute, and that is by measuring the difference between the total and the static pressure, or what everyone refers to as the differential pressure. This is referred to as velocity pressure, and we read this in inches of water. Once this is accomplished, we can calculate by multiplying by 4005 the square root of the velocity pressure, and this gives us our velocity. Once the velocity has been calculated, CFM is achieved by multiplying the area times the velocity. Okay, so our area of our ductwork, and now if our rectangular duct is length by width divided by 144, or if we're using the circle, the area is calculated 3.14 times the radius squared. And this will give us our cubic feet per minute calculation. Please stay tuned for the next in our series of airflow monitoring. I'm going to cover thermal dispersion technology as opposed to what we've covered today, which is their differential pressure, and hope to see you soon. Thanks.